We're here at Olympic Park looking at where Nancy's story began as we look at this spring system that's on here. Obviously, it's not enough springs for that slope. If you don't know it, a human being can fall at 125 miles per hour, which is about terminal velocity for them, in about 120 feet. I believe the elevation difference on this zip line is 500 feet from the top tower way up there to down here at the bottom. Now this is the problem. That retrieval system that's going back up there is just taking one of your zipline riders, or two of them, that passed. You could have charged $35 to send somebody down if you were taking the trolley off at the bottom like we used to at Park City Mountain Resort. So that retrieval system was the first case I looked at, and it broke. And if you notice that this line up here that's being pulled up there, that thing happened to wrap around a chairlift. They don't put chairlifts as close as they did at Heavenly Resort due to that nowadays, but you notice how that retrieval system bounces. That gorilla rope needs to be changed often. And notice the springs on this lower line, which is interesting. Might be a little bit more. Actually, this is the line that we're looking at. The one over, further over, is the extreme zip line. So they have a few more springs than this one here, which is a lesser extreme of the bunch. But our goal is to solve some of the zipline braking problems that are going on in the industry with friction braking trolleys. And you're going to see that because a friction braking trolley starts stopping or slowing the individual down because it's a piece of plastic or rubber that's rubbing on that cable. We are defying gravity with a friction braking trolley. And you've seen my trolleys in the past. They're nowhere near as gigantic as these. These take probably 2 or 3 people to do them. But we do have a brake system, and we prove that. Look at that trolley. It is slowing down all by itself. That's the technology we put on Park City Mountain Resort. Our trolley weighed about 25 pounds. That one looks like it weighs at least 40. And we took our trolley off so we didn't waste money by dragging the trolley all the way back up, because those 2 riders just paid $35 a piece. And now when you drag the trolley back up, instead of taking it off, which about the same time you could do that, you could take that off right there, get it off, move it out of the way, and send another group of riders down. 50% loss in a zip line if you have a retrieval system. Well, granted, it's safer. You're not going to fall off, and the trolley's not going to have issues down there. But if you have the right training and proper guidance, regular days, you're going to be fine. Here we got this lesser zip line. It's another zip line here at Olympic Park, and you notice that these guys are having a ball and they're slowing down. You know, the goal of a fail-safe trolley is to just touch the springs, not fully collapse them. And that's exactly what you want. And the nice thing is look at that guy. These guys are lightweight riders. Lightweight riders. And the lighter the weight, the slower they came. So we're not weight dependent with friction braking trolleys. Friction braking trolleys at Olympic Park do the job. But that retrieval system right there is costing Olympic Park 50% of their revenue. 50%. And their springs are just not what we have. And we've got a better trolley. We've got 5 more patents from our Olympic Park, or original Park City Mountain Resort. We have solutions, and we are responsible. We want to share these solutions. See the retrieval rope that he's pulling down? That's the thing that wrapped around a chairlift and dumped out the honeymooning couple at Heavenly Resort. But yeah, friction braking trolleys work, and you just saw that. Thanks for watching.